Continuing with our idea of strings, on the last video we saw that you can compare strings using the logical operators equal to, as in A equal to A, or not equal to, as in A not equal to capital A. But then we asked the question, well, what do you do with greater than or equal to, less than, or less than or equal to? Because it's sort of obvious to see that lowercase a equals lowercase a, and lowercase a is not equal to uppercase a. But how do you say what's the result of is lowercase a greater than capital A, or for that matter, is the word lowercase apple greater than the word uppercase ants? You know, how do you compare strings, and how does the computer go about doing these logical operators with strings? Right? Well, that boils down to having to understand a little bit more about computers and how they work than you may already understand. And so let's talk about something called, in order to understand this, we have to talk about something called the ASCII code, ASCII, which stands for the American Standard Code for Information Interchange. Let's see if I can fit that in here. Interchange. Okay? The American Standard Code for Information Interchange, which is known as ASCII. Okay? And what ASCII does is something that is recognized the world over, and there's also a broader version which is called Unicode, which is the worldwide universal code for this. But what's actually being done is this, and let's break it back down to how the computer works. Keep in mind, inside your computer only thinks in terms of ones and zeros. Okay? It does not think in terms of numbers. So if you have the letter A, the computer can't see that. It doesn't understand what that is. So you have to represent that A, you have to represent that letter A with some kind of patterns of ones and zeros. Okay? And the ASCII table is how we represent. It tells us what the A is represented as. What I mean by that? Well, okay, so we represent, instead of representing the character A, the computer recognizes it as a series of ones and zeros. Maybe something like this, actually. And so it recognizes it as, and this is called an 8-bit code because there are 8 pieces of information here, and they represent ones and zeros. Don't want to get too far off track. That 8-bit code there happens to be the number, represents the decimal number. This is called the binary code, binary, and this is the decimal representation. Well, since we're humans, we don't think and operate in binary. The computer does. We operate in decimal. So if you look at any ASCII table, which I'll show you on the next segment of the video, if you look at any ASCII table, most of them have a binary representation. They also have an octagonal representation, or an octal representation, and they also have a decimal representation. The decimal is the one we're going to deal with because that's how we usually count. So all that said, what it's saying is that the letter lowercase a in the computer is represented by the number 97. Okay? And this is what you really have to know to get back to our question of how do you compare strings. Okay? So let's look at some ASCII codes and how they work, and then I'll show you the table, and then we'll go to MATLAB and I'll show you how they play out in MATLAB and work in MATLAB. Okay, so Uh, ASCII A, the code for ASCII A, lowercase a, is 97. And then the code for ASCII B is 98. The code for ASCII C is 99. And so on and so forth, all the way down to ASCII Z, lowercase z, which is ASCII code 122. Okay? If you look at uppercase A, it actually starts at ASCII code 65. And ASCII B is 66. And ASCII uppercase C is 67, all the way down to uppercase Z, which is ASCII code 90. Okay? If you come and look at a couple of other special ones, the digit 0. Now keep in mind, the computer recognizes the value 0 as decimal zeros, as binary 0000000. That's the value 0. But this is the character 0, the digit 0. Okay? And so it represents that as ASCII code 48. So the character 0 is actually ASCII code 48. Once again, character 1 is ASCII code 49. Character 2 is ASCII code 50, all the way down to the last digit, which is 9, which winds up being ASCII code 57. Okay? And so these are characters, these are digits, character digits, not numeric values, but character digits. Okay? And then you come over here, and then the other one that is of importance is the space character. The space character is very important in terms of formatting, in terms of getting our point across and communicating. So the space is a character too. I'll represent the space character with two quotes, single quotes sort of spread far apart. Well, that's ASCII code. That character, this is a character, although it's hard to, you can't see it, but you see its effect. It is ASCII code 32. So the space character is actually ASCII code 32. Okay, so the ones that I will ask you to know are lowercase a, uppercase a, digit 0, and space. Well, with the lowercase a, uppercase a, and digit 0, if you know those, you know the rest, because you know that all the lowercases fall in sequentially after 97. You know all the uppercases fall in sequentially after 66, and you know all the digits fall in sequentially after 48. And then there's the space that I'd like for you to know, because it's going to show up if you convert strings that have spaces in them into their ASCII equivalent, which we will do in the next video. But next I want to go to the internet actually and illustrate the ASCII table so you can see it. And then I'm gonna this will conclude the introduction of the ASCII code, and then we'll go and do some operators on the ASCII code, on characters, which shows how they relate. Before I get there, so what I want to do here is just show you the ASCII table. You can get it on any website by Googling ASCII, ASCII. And so this is your standard ASCII table here. It has different columns of numbers. It has the decimal base 10 form. HX stands for hexadecimal, that's base 16. This is base 8, and then you have HTML, and then you show the character. Just wanted to point out that the character space has decimal ASCII code 32. The digit 0 has ASCII code 48. The capital letter A has ASCII code 65. And lowercase letter a has ASCII code 97. So this is the basic ASCII table. You can get anywhere. While we're here, Let's talk a couple of things. Well, there's an extended table because you can see this one only goes to 127 characters. You can actually take it all the way to 256 characters. This 0 to 255 is 256 characters, and you get these extended characters that you may use in other languages. You have other currency delineations here. You have some characters. You have some Greek letters. All of which are used as extended characters, which you may have used in a word processor before. But we're sticking primarily with the basics here. Also, I'd like to point out that it gets broader than this. You can expand to Unicode. Instead of using 8 bits, you can use 16 bits. So you get a whole lot of characters. So you can come in here and do Arabic characters like these. If you're using Unicode, this enables different keyboards. Sure, many of you may have friends or may have your own. Being able to switch a keyboard into a different language to use a different set of characters is very helpful. And so Unicode does that. And these are all standards so that all computer manufacturers worldwide are using these same codes to talk to the machinery. You even have things like geometric shapes here. You have, let's see, currency symbols. They're here. So all of these things enable computers worldwide to communicate with each other and with the humans that use them. So, but we're going to focus once again just on the basic ASCII code. Values I want you to know are 32 for the space, 48 for the 0-digit, 65 for capital A, 97 for lowercase a. Knowing those will allow you to get to all the other values because these are sequential with the digits, sequential with the capital letters, and sequential with the lowercase letters. So there's the ASCII table. I just wanted you to get experience seeing it.